Alright, in the last video we saw how to add, subtract, divide, and multiply functions. Now we're going to see how to combine them in a different way called composition. And this is where you take one function and you feed it to another function. And so the composition of the function f with g is denoted f of g of x, and that's read, that little o is read of g. And the idea here is that you're going to take x, you're going to feed it to g, and then you're going to take the output g of x and feed that to f. Okay, so you should always just kind of read this as like x is the inside thing, g is the next inside thing, and f is the outermost thing. And so we read these things from inside to outside. So a cartoon of this would be the following. You have x, you're going to feed that to g, right? G is this little box here. You feed that to g, what comes out is g of x. And then you feed g of x, the output there, you feed that into f of x. And what gets spit out is f of g of x. Again, so what's inside the parentheses is like what's being fed into that outer function. Okay, so again, this was x went in, g of x came out, g of x goes into f, f of g of x comes out. Okay, so now we're asked to find the following compositions of functions. So f of x is 7x plus 1, and g of x is 2x squared minus 9. So to compute f of g of x, we're going to take f, and we're going to feed g of x into f. So we want to take, let me just write f of, and now g of x is 2x squared minus 9. So I'm replacing g of x with its name, 2x squared minus 9. And now we're going to stick that into f of x. Well, f of x was 7x plus 1. So wherever there was an x in f, we're now going to stick in 2x squared minus 9. And now we just simplify. So this is 14x squared minus 7 times 9 is 63. And we have a plus 1. So I think I have f of g of x is 14x squared minus 62. Okay, in B, we're asked to find f of g of 2. So I'll just write that this is f of g of 2. Well, g of 2 is 2 times 2 squared minus 9. 2 times 2 squared minus 9, that's 8 minus 9. So this is really f of negative 1. And then again, f is 7 times x plus 1. And so here, g of 2 is negative 1. So 7 times negative 1 is negative 7 plus 1, which gives me negative 6. So f of g of 2 equals negative 6. And you might be wondering, couldn't we have just stuck 2 into 14x squared minus 62? And the answer is yes. So let's just check that real quick. That this f of g of 2, if you look back at what we solved for f of g of x, we could have taken f of g of 2, we could have written that as 14 times 2 squared minus 62. And so that would give you 14 times 4 minus 62. So 14 times 4 is 56. So we'd have 56 minus 62, and so you get negative 6. So either you can do it like we did in part B, or you could just take what we solved for in part A and stick in 2. Either way works. Okay. Now, in the last example here, in part C, we're asked to find g of f of x. So now you have to write this as g of f of x, where f of x is 7x plus 1. So this is g of 7x plus 1. Well, g is 2x squared minus 9. So I'm going to write that as 2 times something squared minus 9. And I'm sticking in 7x plus 1. So now to simplify this, we need to FOIL 7x plus 1. So let me do that first. 2 times 7x plus 1 squared would be 49x squared plus 14x plus 1. So this is just 7x plus 1 squared here. And then we have minus 9 outside. Okay. Now I'm going to distribute the 2. So this becomes 98x squared plus 28 plus 2. Sorry, plus 28x plus 2. And so that becomes 98x squared plus 28x minus 7. Okay. Now, the last thing that you should note here is that f of g of x is 14x squared minus 62, and g of f of x is 98x squared plus 28x minus 7. And so in general, g of f of x is not going to be equal to f of g of x. And that's a common mistake for students. They give you completely different functions, whether you compose g of f or if you compose f of g.